So as we continue our kind of crash course in chemistry, let's talk about bonds. So there's going to be two major bonds that we're going to look at, ionic bonds and covalent bonds. But this idea of bonding, the idea of taking different types of matter and combining it and rearranging it, that's chemistry. And so what we see here in this picture is a plant doing photosynthesis. It's producing oxygen from using the energy it derives from light. It's making sugars, and you can see the bubbles on the leaves forming as the oxygen is produced. It's rearranging matter. So when we talk about chemistry, we can talk about this idea that substances, when we study them, their composition and their rearrangement, basically how they swap electrons and interact with electrons on an atomic level, that's chemistry. Now, when we combine different substances, it's going to be all about electrons. So remember, electrons are the negatively charged particles that orbit the nucleus of the atom. And we have as many electrons in kind of a natural state of an atom as we do protons in the nucleus. So remember, those charges equal out. For every plus, you have a negative in that natural state. Now, electron orbitals, as you take chemistry, are a little bit more complicated than what I'm showing you here, and this is just a glimpse of that. The idea that the shape of the orbital changes, we have many layers, but what we're going to focus on when we talk about this very simple biological chemistry is the electrons in the outermost shell, the outermost orbit. And you can see that as we go from the first shell to the second shell, you can see that they're getting further and further away from the nucleus. And that outermost shell is called the valence shell, the shell that's actually going to be able to interact with other types of matter. Now, when we start to combine matter, we can have two kinds of combinations. We can have compounds, which are unique substances composed of two or more elements. It's a more general term. So anytime you have more than two types of matter combined together, you have a compound. Now, a molecule then is two or more atoms covalently bound to each other. And the covalent bond is the idea that we're going to talk about when electrons are shared to make a stickiness, a bond between two different elements. And most of the molecules that we're going to look at, most of the things that we're going to look at in biology are molecules. They are, in fact, held together by covalent bonds. And you can visualize this with the balls held together with sticks, or this picture of a molecule down here. And I want to show you as many of these as I can so that you become familiar with them and they're not something foreign to you. Now, again, talking of bonding, let's start with our first type of bond. These are two very general bonds, but we have to start somewhere. We'll talk about ionic bonds. Like I said, it all comes down to electrons. Now, what we're going to do is make sodium chloride, or table salt. So table salt is composed of sodium atoms and chloride atoms. Now, again, we talked about this idea that it's the electrons in the outermost shell that are interacting. Now, in an ionic bond, we're going to form what are called ions. And an ion is an atom or a molecule with a net positive or negative charge. Now, this idea of charge is simply a characteristic that we're describing about any given thing. Positive and negative, these opposite characteristics, are attracted to each other. So electrostatic attraction, this force in the universe, is going to push these two together if you have a positive and a negative. Similar signs will repulse each other based on the same force in the universe, and that's just physics. That's just the way it is. So two positives will push away from each other. It's like when you take a magnet and push the two north ends towards each other, you feel the repulsion. Yet north end and the south end stick together. They're attracted to each other. It's basically the same force. So, sodium and chloride. Now, it's called an ionic bond because it's formed from two ions. Sodium has but one electron in its valence shell, in its outermost shell, and chlorine has 7. What this is going to do is talk about the idea of electronegativity. Chlorine is very electronegative, and we're going to come back to this idea later when we talk about water. But chlorine is very electronegative. It wants electrons. And sodium is not nearly as electronegative. It has one little electron in its outermost shell. sometimes it's easier just to get rid of that electron, give it up to chlorine who really wants it badly, and become ionized. And that's ultimately what's going to happen here in any ionic bond. So you get sodium, which gives off, lets go of that last outermost electron, and chlorine, which grabs it and takes it. Now, sodium has one less electron than when it started, and it has, therefore, one more proton in its nucleus than the number of electrons surrounding it. It becomes positively charged because protons are positive. Chlorine, which now has one more electron than it does have protons in its nucleus, is now negatively charged because electrons are negatively charged. So it becomes a negative ion. Positive and negative attract, boom, these two stick together like two magnets, you have an ionic bond. Now the other thing that's going to come into play here, which we're going to also talk about when we talk about covalent bonds, is what's called the octet rule. There is a tendency of atoms to want 8 electrons in their valence shell, their outermost shell. So when you go back and consider sodium and chloride once again, you can see that sodium, were it to lose that outermost electron, it has now the next most inner shell as the outer shell, and it has 8 electrons in it. It has complied with the octet rule. Chlorine, which has 7 electrons in its outer shell, only needs one more to make 8. When it grabs that electron from sodium, it now has 8. It has also complied with the octet rule. So this tendency overlaid on the number of electrons in the outermost shell dictates the chemistry of different elements to a certain extent. In this case, when you put these two together, chlorine rips that electron away. Everybody has complied with the octet rule. You form two ions stick together, boom, that's an ionic bond. Right? So when you get this kind of ionic bond, you get a salt, this crystal that we dig out of the ground and then crush and put on our food. This is table salt, sodium chloride. Again, with reference to emergent properties, sodium here on the left is actually a soft metal. That's sodium in its pure form. It's actually quite reactive. You throw that into a pool, it explodes. Chlorine is a gas that is poisonous. It will kill you. You see this greenish gas in the bottle. So these two elements that we would never think to interact with in their pure state, when you combine them in table salt, it's tasty goodness. That is an emergent property. Right? So a property that emerges from the organization of the system. By organizing these, sodium for every chloride, you get salt, and it's something that you deal with on an everyday basis where you wouldn't before. So ionic bonds, I'm ripping the electron away, I'm forming ions, positive and negative are attracted to each other, we stick together like magnets. Covalent bonds, then, are going to be a little different. In this case, the octet rule is still going to have a role, but instead of pulling an electron away from a different atom, we're actually just going to share. So in a covalent bond now, I'm going to strive to comply with the octet rule. What I'm going to do is offer an electron and get an electron. And that is going to hold these two atoms next to each other. So if you jump to water here, you can see oxygen, which happens to have 6 electrons in its outer shell, has room for 2 more. It needs 2 more. Honk, remember H-O-N-C? O, 1, H is 1, 2 is oxygen. That O says I need 2 more electrons. Well, hydrogen has 1, and it needs 1 more. It's the one thing that the octet rule actually just becomes a rule of 2. It's the one element out there that's like that. So hydrogen's only looking for 1 more, oxygen's looking for 2. So if it sees 2 hydrogens, it can say, hey, if you are willing to share your 1 electron with me, I'll gain 1 more electron, and I'll share 1 of my electrons with you, and you'll gain an electron. If it does that with 2 hydrogens, it's gained 2 electrons, formed 2 bonds, and now is happy with the octet rule. Each hydrogen has received another electron. It has 2. It's happy with its equivalent of the octet rule. You can see that with methane too. Carbon wants to make 4 bonds. Honk. H-O-N-C. 4 bonds, 4 hydrogens. So this is going to be the foundation of connecting elements, atoms together to make molecules. Ultimately, those molecules are going to come together to make cells. And we're going to explore those different types of molecules as we move forward in the course.